Hi, everybody. My name is Jeremy Fink. I'm a product development engineer at Hydro International. Today, what I'm going to be talking about is a trash study that we conducted near our office here in southern Maine. And so I'll start off by talking about why we conducted the study and how we developed the methodology around the study. And then I'll go on and discuss the results of the study and summarize them in some conclusions that you can take away and use to inform your own intuition around trash in your own work. Just to start, a little bit of background about Hydro International for those of you who might not have worked with us in the past. Hydro is based out of a home office near Bristol in the UK, but we have two offices in the United States, one in Portland, Maine, where I'm located, another one located outside of Portland, Oregon on the West Coast. But we have distribution channels all around the world and products installed all around the world. And so in this way, Hydro is really truly a global company. And Hydro does water treatment. We have a suite of products that are designed specifically for the stormwater treatment market and flow control market. Another set of products that are products that would be installed in water treatment plants. And then we have a suite of products that are designed specifically for the needs of the CSO spill areas and meets those specific design requirements. So between all of these product segments, we have over 120 patents around the world and continually are developing new products and new patents for to meet customers' needs as they arise. So over these 30 years of product development and innovation, we've developed a foundation of tools that we use to inform our design process. We have two hydraulic laboratories, one that is in Portland, Maine, where I'm located, and another one that's in Clevedon, England, outside of Bristol. And so these two laboratories provide a lot of research capacity. And then beyond that, we have a wide install base of thousands of separators and pieces of equipment and filters installed all around the world. And so we can use that install base to get some field information as well. So the combination of the lab data, the field data, that provides us a really good foundation for us to conduct our product development efforts. We're very proud of our collaborations. These are just a few of the universities that we work with in the US and in the UK. And these collaborations are sort of a two-way street. Sometimes we are giving the university products that they study as part of their own research, and sometimes we're purchasing from them research and intellectual property that they've developed, and then we go on and commercialize it as a product, as a Hydro product for the market. So this is a great effort for us. And then finally, we work very closely with regulatory bodies and certifying bodies around the US and around the world. You'll see quite a few state DOTs and state DEPs in this list here, but there's also international accreditation bodies, European, some North American, Ontario, Calgary, Auckland, New Zealand is represented there. So you can see that there's a sort of a wide reach of certifications. And so we work with these groups to develop regulations and inform the regulations that they're putting together. And then we also work with them to test our own products and prove that they meet the certifications that are designed and that are required. So now I'll go on and talk a little bit about this trash study here. Trash is by far the most visible of the pollutants that we are asked to address with our products, and it's usually the pollutant that produces the most outrage in the community as well. Not only does it degrade the natural habitat and can be shown that it does that, it has perceived public health threats, actual public health threats, but it is the visual impact of trash that really gets people motivated. And this is doubly true in coastal communities like ours in southern Maine. Maine has a thriving tourism business, and it has a reputation for pristine waters, pristine forests and land, and so when that reputation is marred by trash, it really can impact, in a true sense, it can impact economically with tourist dollars. So this is one reason why trash is very important. But the other is that the trash actually affects the ecosystem in ways that we can't even really imagine. You look at these pictures here, plastic trash enters the watercourses and enters the ecosystem and lasts for 500 years or more before it degrades. And so not only is treating trash before it enters the watercourses a smart thing to do, it's also the right thing to do for the environment and as a good steward of the environment. And it's something that is in our power to address. The majority of trash in the water originates on land. It doesn't. There's a small fraction that comes from boats or oil rigs or shipping containers and things like that. But for the most part, it is blown into the water courses from the land. And so of the 2.5 million plastic bottles that we use every hour and 1 million plastic bags that we use every minute, a good portion of that has the potential to end up in the water courses unless we are careful about containing it and recycling it. And so forward-thinking cities and jurisdictions, Los Angeles, San Francisco, Baltimore, for example, have adopted zero trash TMDLs, which is total maximum daily limits. So they are saying that there is no amount of trash that you are allowed to have escape your site. It is capped. And this is a smart idea and is probably the direction that more and more cities will be heading. So from a product development standpoint, this is interesting to us. This chart shows the range of products that Hydro International supplies. And you can see this is a continuum of solid sizes. So it starts with, on the left here, very, very small solids that are smaller than a micron, and then moves to larger things that are non-settlable, what's called colloids, that just stay in suspension, and gets larger and larger until you get to things that are bigger than 1 millimeter, which to us is quite big. And so the products that you would use to treat these have a certain amount of sophistication that comes with removing the size of material that you're targeting. So, for example, if you're targeting a very small particle size, you need a much larger, more sophisticated piece of equipment than you do if you're targeting something that's a fairly large solid, that might be able to be screened out, and then you can have sort of a simple system. And so this is where hydro sort of started in this range with some what's called vortex separators, removing solids around 100 to 500, 1,000 microns. But this was a change for us in the stormwater industry to say, well, what can we do for trash? And we developed this product here. This is a product called the dry screen. And it's called the dry screen because it was originally developed as an elevated screen above the water level that could capture leaves, twigs, sticks, things that organic material that would sit in the water of the sump of a manhole and start to break down. And as it breaks down, it releases nutrients that leach out, and those nutrients travel downstream and pollute the downstream water bodies. So this is one purpose that this product has, the dry screen. But the other thing that it does very well is separate trash and remove trash from the system. And you know, it is so simple. You've probably already intuited how it works, but I'll explain it. Water comes in this inlet pipe on the left here, and the flow is sort of distributed by this flow splitting element in the front, which I'll explain a little more later. But it's then distributed over this screen, and there's a horizontal screen here and a vertical screen weir that is located at the end. And so this way, when the water exits the system on the right-hand side here, it is free of any debris, and you've got water that's visibly clear. So this screen is made out of fiberglass. You can walk on it, and it's got openings that are about 3/4 inch square. You see another view of it here. The flow distribution component at the front was designed to encourage full use of the screen. And one thing that we've learned about screening products is it's really all about preventing blinding on the screen. Blinding is a fancy way of the screen kind of becoming clogged and matted with material. And you know, we're trying to avoid that by distributing the material as best as possible over the entire screen. This also serves to spread the water out over the entire vessel so that particulate matter is encouraged to settle out into the sump of the concrete vessel. And so this flow splitter was designed using simulation software called CFD, computational fluid design, and you can see these views sort of on the left here are some outputs from that analysis. But that's the science behind this product. And this is what it looks like when it's installed. I think this one was in either Wisconsin or Minnesota. And you can see that in this case, the storm is now ending, the water level is beginning to drop. And you can see sticks and twigs and plant debris, but there's also some cans and looks like maybe a spray paint can or two in here. And so this material is now, as the water level drops, it'll be deposited on the screens and eventually will dry out and fall off, and the screen will be ready for the next storm event. This is what it looks like when it's actually installed. And so, you know, just a kind of another view of it here with you can really see the fiberglass screen, but you can also see how the screen area has been maximized to match the footprint of this vault that it's in. And this was designed this way specifically because we want to have the largest screen area possible in order to prevent blinding in use. So we felt pretty good about this product because we know screens, or so we thought. You know, this is, we have, Hydro has a lot of screening products in our portfolio, but they've all been targeted towards the wastewater market or the CSO market. And the needs of those markets are slightly different. If you have a water treatment plant, you have power on site, you have water on site, you have staff on site to maintain the equipment. And so as a result, you know, a product like this, which is called the Hydro Micro Screen, this product works very well in a water treatment plant. There, inside here, there are scrubbers that keep the screen clean, and it rolls or has a belt shape. The screen is on a belt, so it kind of rotates through the water that needs to be screened, and it's a fairly sophisticated piece of equipment. This system down here, the sludge screen in the lower left, is another piece of equipment that is used in water treatment plants, and it's a cylindrical screen, but there's a sort of a screw auger that forces the material through the screen and keeps it scrubbed clean. And again, it has a sophisticated maintenance component to it, and that won't fly in a stormwater situation. These are maybe sort of halfway in between the heli screen, the hydrojet screen, the hydrostatic screen. These are all screens that are specifically designed for CSO spill areas. And the heli screen being the most sophisticated, this one requires power. It's actually pictured here in the center photo. It's a cylindrical screen, and you can barely see inside. There are some flights of a brushed auger that runs up and down the screen in order to push the material. The material gets captured inside the screen, and so it pushes the material out to the end where it can be collected. But that requires power, it requires maintenance, and in a stormwater situation you don't have that. The hydrojet screen and the hydrostatic screen don't require any power. Again, the hydrojet screen is a self-cleaning screen, similar to some of these other ones, but this uses hydraulic, sort of an oscillating hydraulic head to keep these screens clean by forcing forcing a backwash cycle, essentially. But it's expensive. There's lots of stainless steel in this product, and you would have, you know, this is more of a product that a municipality would buy in order to put at their CSO outfall. And the hydrostatic screen is the same thing, but this does not have a backwash, but it's still lots of stainless steel. It has a steel corrugated screen that's coated with a non-stick coating, and it's typically out of the price range of a developer who's putting something in and needs a screening solution for their site. So we said, all right, we need to design the right tool for the job. We need to design a stormwater screen that can get most of the trash out of the system and won't break the bank. Will be able to be affordable for a developer putting together a site. So we know screens. The next step is, do we know trash? Do we understand the material that we're trying to remove from the water course? Well, this is a picture from our study. I'm here with a clipboard and a pen, trying to appear studious and looking at the results of our collection effort here. This is why we launched the trash study, was to better understand the material that we're removing so that we could design a smart product that is the right tool for the job. So, details about the study. The Long Creek trash study. Long Creek is an impaired watershed that encompasses 4 different towns. So Portland is up here, and then 2 neighboring communities, actually 3, South Portland, Scarborough, Westbrook. Our office is up here in Portland, right on the line. It's one of these buildings over here. And this this creek has been impaired. Probably it started as a shopping mall right here. You can see this large impervious area that was built in the 70s, late 70s, early 80s, and because of that, a lot of the branches of this creek were culverted, diverted, and the water quality started to decrease in this whole catchment area. And so maybe about 10 years ago, there was a effort launched to improve the water quality in this watershed, in the Long Creek watershed. And so this was put together, and the support was required of all of the businesses that were within this watershed. So now we're kind of zooming in on the area that we were studying. This large impervious area, again, is the main mall. And we were looking at this portion of Long Creek that had been diverted around the development area of the mall here. And it's in a channel that's maybe 25 feet wide, and scaling off of Google Maps, I figured it's about 0.6 miles long. So this is just under 2 acres of sort of long, skinny channel along the mall here. And we put together this effort with a few partners here. The Long Creek Watershed Management District is the organizational body that works with the business owners in this area and helps them with the ecological efforts there. And the University of Southern Maine has had some particular experience with trash studies in the past, so we were happy to work with them, and I'll give a little bit of more detail about that in a minute. And then the Cumberland County Soil and Water Conservation District, these are the guys who have some funding to chip in with studies like this and with efforts like this, and so we partnered with them as well. The Long Creek Watershed Management District has, as part of their website and the literature, these fact sheets, and you know they do a great job of informing the business owners of what they should be doing to improve the water quality in the Long Creek. When you look at these, they look like very intuitive. You know, you look at these and you think, it's impossible that people have to be reminded of these things. But it is, even though it seems like it is an obvious fact, these are best management practices that bear repeating. So, for example, there's one on here in this dumpster management fact sheet that I have in front, that you should empty them regularly. They are scheduled to be emptied regularly before they are full, and if you have garbage bags coming out the top, like, you know, around Maine, you have seagulls and crows and things like this that will get into them and spread the trash everywhere, and before you know it, it's blown into the water course. So empty your trash bin regularly. And also the last one here, pick up the perimeter. The area around the dumpster should be maintained daily. If the garbage falls out of the dumpster, it needs to be picked up before it's washed away or blown into water resources. So these are obvious if you're looking for them, but they need to be written down. They need to be reminders for the business owners. And these guys at Long Creek Management District do a great job of that. USM was uniquely qualified to help us with our study, because there's a researcher there who just completed a trash study in the city of Portland about our open-top recycling bins. And we have these sort of small tote bins that we use, but the problem is when the wind blows, if these are overflowing or close to the top, trash escapes and ends up all over the ground. So he calculated 20,000 pieces of litter for every 1,000 households. That's 20 pieces of litter per house. That sounds right, but it adds up annually. 4 tons of litter for every 1,000 households. So it's it's quite it's quite impressive how this can add up. And so we were very happy to get some participation from USM as well in this study. So as we started thinking about the methodology that we would use for our characterization, and we did a literature review and found a recent study from 2 recent studies of the Los Angeles River. One was conducted by the Friends of the Los Angeles River, and it was written up in Stormwater magazine in the January-February issue if you want more information about it. But they did a study. It must have been, I don't have the date on here, but it must have been 2014, 2015, something like that. They did a survey of trash where they collected trash from several different branches of the LA River and sort of collection areas here in the watershed, gathered it up and sorted it into categories, 11 categories. And so we thought, well, this is maybe a good place to start, because if we used similar categories, then we could compare our results to the LA River results. And the LA River study was really had a big impact. Because of that LA River study, the city of LA decided that they were going to install trash screens on all of their catch basins. And so this was 38,000 catch basin screens, like the one you see here, installed around the city of LA, along with another 10,000 catch basin inserts, which are sort of bags or baskets that go inside of a catch basin, and then a few other BMPs as well. But this was a major undertaking, and was the result of this City of LA trash study. So these were the categories of trash that were identified in the City of LA study, and that we used as well. And you know, when you're doing a study like this and you're looking at a piece of paper and you're asking yourself, is this a snack wrapper, or is this a piece of paper, or is this food service packaging? There clearly is a little bit of human judgment that goes on in that sorting process. But we did our best to sort the trash into these categories, and here you can see these are some folks from our office doing the glamorous work of research by picking up trash on the side of the road. And you know, this was great, because not only were we getting some good data for product development and about trash in the area, but also it gave us an opportunity to be good stewards of our neighborhood. And this was an area that needs attention and needs some care to the ecology. So it was good to get out in the field, and everybody pitched in and did a cleanup day, and we took all the trash from this channel and bagged it up. And it's a very manual task, you know. This is what the process looked like. We were picking up trash from the side of the road by hand, putting it in a bag, and then the bags were all collected and were taken to a station. You can see here these were students from USM helping us with our data collection here. They're weighing each bag, so every bag that came to a station was weighed and cataloged, and then a subsample of the bags were opened up, and the trash inside was sorted into the 11 categories. And so we had buckets for the different categories here. And so we would sort it into the different categories and then measure the weight and volume of the trash that was in those different categories. And then lastly, we would be putting the trash on top of the screen This is the screen that is the hydro dry screen material. It's the fiberglass screen. And so the idea was, let's get a sense of how much of the trash that was captured would be collected by the 3/4 inch hydro dry screen material. And so this is the grid that's used, and we could measure how much material fell through the bottom. So the results. One of the most interesting parts of this study is that because we conducted it 2 years sequentially, we have two very different sets of numbers in a sense. 2016 was the first time we conducted this study, and there was no indication of when the last cleanup had been held. And so we cleaned the area, and we collected quite a bit of trash. Almost 600 pounds of trash were pulled from that perimeter around the mall, 55 bags. But when we came back a year later, now we were looking at something that was closer to an annual load. It was just about the same time of year. We used the exact same area that we had cleaned before. And so now the number of bags was cut in about half. The weight was cut in half as well. So this now starts giving us a sense of annually what is the trash load that accumulates in this spot. The subsamples that we took from 2016 and 2017 ranged from 20 to 25% of the total bags collected. And so from that, we were able to get an average bag volume and a total volume of trash. Volume is really the way that it makes sense to measure trash, because so much of it is very lightweight material, and as you collect it, you run out of space much faster than you run out of then it becomes too heavy to work with. So you can see here, when we look at the total volume difference between 2016 and 2017, our volume we collected maybe a quarter of the volume of trash in 2017 than we did in 2016. Just to give you a sense of how big this is, we captured about as much trash, if I remember this right, 2017 this is about as much, it was like 3 cubic yards, which is like the size of 3 refrigerators, let's say. And so you can imagine, 3 refrigerators compared to maybe here 12 refrigerators or so in 2016. If that visual helps you imagine the volume. Bulk density, how much the trash weighs per, what the density of the trash is, essentially, what the weight of the trash per volume that it takes up. This is maybe only interesting to us from a product development standpoint, but it's also interesting to people who have to truck trash around for part of their day. You want to know, if I fill this truck or this space or this storage area up with trash, what is it going to weigh? And so this was interesting. Because we had the total volume and now we had the total weight, we could measure this average bulk density. So we have a range here of around 1/3 to 1/2 of a pound per gallon. And some of this is because when we did our study in 2017, it was raining that day. And so the trash was wet and probably a little bit heavier than it was in 2016. But now we have kind of a max and min. We have a rough idea of a range of bulk densities to work with. Now, when you compare the results of the Maine Mall study to the LA River studies, there's some interesting trends to note here. The plastic film that we saw at the main mall, which was kind of the number 2 pollutant by volume that we collected, plastic film showed up as one of the top 3 pollutants in all 3 studies. And this is obvious to anybody who's looked around and seen plastic bags caught in trees and this sort of thing. Plastic film and the carrier bags and shopping bags that we use, it's a very long-lasting pollutant. It's very durable, and it's very mobile. It picks up and flies away. And so we found lots of this, and clearly other studies have too. So that's very interesting that showed up in all 3 studies. Food service packaging, although it was very high in the main mall study, still featured in the middle of the LA River studies. And this is maybe this could probably be attributed to the fact that when the main mall area that we were cleaning up was right outside of a food court. So of course there's going to be lots of food service packaging, but still worth noting. And then paper is in the top 3 of our main mall study and the City of LA study. It's further down the bottom in the Friends of the LA River study. However, this is maybe due to the human judgment of sorting trash, when maybe they were better at the Friends of LA River of looking at the paper and saying, oh, we're going to call this a snack wrapper or a food service container, while somebody else looked at it and said, this is paper. So still, the fact that paper shows up at the top 3 of 2 out of the 3 studies means that it is a pollutant that's worth noting. So year on year at the main mall, the top 2 categories didn't change. Plastic film, grocery bags, food service packaging. This made up 50 to 60% of the trash that we collected in 2016 and 2017. And you know what's maybe good to note about this is these are pollutants and trash sources that are very controllable. You know, they are coming from the mall, they are coming from the businesses there, and so with a little bit of effort in recycling and trash maintenance, maybe those could be taken down without too much trouble. From the standpoint of the design of the dry screen, the bulk density number was useful for us. We compared it to, when we designed the dry screen, we designed it to hold material that had a bulk density of around 110 pounds per cubic yard. I've switched units here. Now I'm in pounds per cubic yard. And so this was an estimate that the EPA has for yard waste as a bulk density. So if we're targeting 110 pounds per cubic yard, we could safely say, yeah, if trash sort of wet and dry ranges from 60 to 100 pounds per cubic yard, we're in the ballpark. We'll probably have an appropriate design for storing and holding that trash at an elevated platform. The other thing that was useful to see was that 97% of the trash by volume was larger than this 3/4 inch grid. So this was good to know that by using this grid, the system doesn't require quite as much maintenance as it would if the grid was smaller and would blind more easily. A larger grid is more resistant to blinding, but it also would capture the vast majority of the trash that entered. So this was a useful figure for us to get from this study as well. So those are the results, and I'll just kind of sum up with some conclusions here, and then we'll wrap up the presentation. But the conclusions about the main mall, the top three pollutants: plastic film, grocery bags, food service packaging. If those were removed through recycling or through substituting other materials or some other method, the volume of trash load outside this area of Long Creek could be reduced by 50 to 60%. If we assume that the 2017 cleanup was an annual load, then this 2-acre area accumulates about 3 cubic yards of trash annually. And so to clean it, we had a team of maybe 12 people. It takes about 36 man-hours to clean that area. So that's maybe a useful metric for somebody trying to put together a trash plan for that zone. And then from a product development standpoint for us, we feel that we saw that 97% of that trash by volume could be collected on a 3/4-inch screen, and a bulk density of 60 to 100 pounds per cubic yard was appropriate for the trash weights that we saw in that area. And then just to kind of get a sense of what those volumes mean, the Hydro Dry screen comes in several different sizes. The smallest size would have to be maintained. If it was treating that area, the smallest size would have to be maintained twice a year, and the next size up could be maintained annually and still have room to spare. So that kind of gave us some intuition around how big a screen you would need to treat an area for trash. And that's it. Thank you very much for your attention, and I hope you are able to take away some good information from this trash webinar. Bye-bye.